McGill Formula Electric is a student design team at McGill University. We design, build, and then compete a Formula-style race car. The biggest competition that we compete in is called SAE Michigan. There's about 75 teams that come from all across North America and compete in both dynamic and static events. And in 2020, this car was the overall champion. Following the success of MFE 20, we really wanted to set a new ambitious course of action for the following car. Where can we take this design a little bit further? So that fall, they did their design, and then in the winter, COVID hit. And that really disrupted everything. So the team management at the time decided that this car was going to go over a complete overhaul. So we shifted up, we did a 2-year design cycle. But as with any ambitious design change, there's setbacks. Last summer, we didn't finish our vehicle. We weren't able to compete in any of the dynamic events at this competition. However, we were able to achieve 10th place because this team has an incredibly solid understanding of the first principles that make a good design. So one of our favorite things about using Siemens as our design and analysis tool is that it's an all-in-one package. You get to see a holistic view of the whole car in CAD. You get to have all your FEAs linked straight back there. All your simulations are modeled in the exact same environment. And what that enables us to do as we're bringing this into the manufacturing season is keep all of our drawings attached right back to the main CAD of our car, keep our assembly all as one piece, updated as we go, and the whole thing is painted there perfectly.
We always go to the Michigan event with the intent of winning. Sub-goals that we've identified to help us meet that, we're looking to break the North American acceleration record. As a team, we've been working with Siemens for a number of years. We have a very good relationship, and it has allowed us to develop a number of workflows that really streamline our design and allows us to work really efficiently as a team. All of our CAD work is done in NX, so we have what we call the digital twin of the car, and everything will be manufactured exactly as it is in our digital model. In our suspension system, we've used topology optimization in Siemens NX to lightweight some of our bell crank shafts. I believe we've seen around a 50% weight reduction. We've done a number of finite element analysis simulations to really push our weight savings there, and we've actually combined a couple parts in order to reduce weight. One of the biggest areas that NX being integrated with the other Siemens products has helped us with our aerodynamic packages. So we're able to do the CAD in Siemens NX and then transfer that over to Star CCM Plus. It reduces errors in kind of miscommunication, so you don't have your simulation on one geometry and your CAD on another. Everything is always synchronized. And it also really helps us with making sure that we're eliminating interferences.
The team moved to a 4-in-hub electric motor design in the last few years. We've done this both because it helps the performance of the car on the lap time simulation, and also because we wanted to stay ahead of the curve in terms of our design. This has brought some new challenges to the team in terms of cooling. SimCenter AimSim has been really helpful to help us characterize the thermal management of the whole vehicle. So we were able to simulate the whole endurance race where we have the motors and the inverters on our cold plate and cooling jacket geometry in SimCenter and AimSim. We've been able to pick out a new radiator geometry. This ensures that we are pulling enough heat from the cooling system so that the temperature of our motors and inverters remains within the operating range that the manufacturer gives us. We also simulated the geometry for the cooling jacket and the cold plate in CFD and Star CCM Plus. This gives us a deeper insight into how the heat transfer is happening in these geometry. It's also been a good tool to validate the assumptions that we've made in the AimSim model, and we were able to tune the AimSim model with the CFD data to make sure that the system simulation was as accurate as possible. SimCenter Star CCM Plus has great automation capabilities. There is stuff you can do in the software to make sure that when you change a setting or when you change your geometry in and out, that everything that is downstream of that change updates by itself. In the long run, this new template will allow us to train the new members more easily because it is more automated and the pre and post processing is being done by itself. But it can really spend more time designing and less time doing the pre and post processing in the CFD software. I have been an intern at my HTT for the past 6 months. This has really allowed me to learn a lot about the different softwares, where they can be used, what's the strong points of each of the softwares, and where you might use one or another. And it's still really awesome to be involved interesting projects. It's a really good learning experience for me, and this is some experience I can bring to the team afterwards, both with what I've learned, but with the questions I can ask the experts at my HTT as well.